Everyone for joining. I'm going to be presenting today about Oracle Autonomous Databases. I have one favor to ask. I really like my sessions to be very interactive. So if I could ask if you can't be shy and enable your camera so I can see some faces and can see some nods. Or failing that, if you can ask questions in the Q&A panel or also through the chat, that'd be great. As I cannot see any cameras so far, can I get some dialogue going in the chat or questions? I'm not seeing anything now, so I'll be keep prompting you. So I'll be looking for yeses to make sure you're still following me. If someone's not camera shy, if they can go on camera and nod, that'd be great. Okay, right. So I'm going to kick off now. So if you're here for Oracle Autonomous Database 101, great. Otherwise, you're at the wrong presentation. Right, so let me just put my cursor on. All right, should be able to see that now. Perfect. Okay, so a little bit about myself. I'm a principal consultant within advisory services here at version 1 within the UK. I'm an Oracle certified master, also a Oracle ACE. I have deep expertise in Oracle, in particular the database or core Oracle tech. Have a deep understanding of Oracle max availability architecture, so that's rack and data guard, and also Oracle engineer systems, so that's Exadata, Oracle database appliance, as well as all public clouds, so that's moving Oracle workflows to them. As you can see here on my slide, you can see a big QR code. If I can ask if you could scan that, that will take you to my blog, and also we'll have a quick, easy access links to my social media. Okay, a little bit about my employer. So I work for version 1. We specialize in Oracle, Microsoft, AWS, and more recently Red Hat. We have 2,000 employees across 12 offices. So they're across UK, Ireland, and more recently India. We've been around now for 25 years, helping our customers with IT. Okay, some examples of our customers here. We work across all industries and sectors, so some of them, in particular, if you're in the UK and Ireland, you will recognize. Okay, now we've got all that out of the way, onto the more important topic of Oracle Autonomous Database. Okay, so the key question is, what is an Oracle Autonomous Database? So I went on to Oracle's website. You can see the link here. I actually did this last year and rechecked it again more recently on the 14th of October, and Oracle has kept the same marketing spiel. And effectively what Oracle is saying, it's a autonomous database is a cloud database that uses machine learning to automate database tuning, security, backups, updates, and other routine management tasks traditionally performed by DBAs. Unlike a conventional database, autonomous database performs all these tasks and more without human intervention. So that's all great, sounds great, really nice marketing spiel, but actually what does that mean under the hood? So that's what I'm actually going to talk about today. Right, so for me to be able to answer the question of how is this made possible, I need to explain the 3 facets of an Oracle Autonomous Database. The first one being it's built on top of the Oracle database we all know and love. It's on the 19C cut on the Enterprise Edition. Some of you may be thinking, well, Oracle latest release is 21C, and as far as I'm aware, it's still not yet available for production workload, with the exception of the always free tier, which I will come on to later. So it is the standard Oracle Enterprise Edition, and the only thing that differs from the Enterprise Edition we have and what's in Autonomous Database, it has an additional code set which is only activated when it's Autonomous Database, which allows for all the automation, etc., etc. The next thing then, it runs on the best database platform, which obviously is the Oracle Exadata machine, which is part of the Oracle Engineer system. So the beauty of Oracle Engineer system is it's a full end-to-end solution. So that just means it does include the Oracle database tier, but it also then includes the operating system tier, and then moves all the way down into the hardware. So that includes storage, networking, etc., etc. So it comes as a pre-engineered system, pre-tested, pre-configured, and it's predictable. And because Oracle own the end-to-end stack, it allows Oracle to do offloading. And what I mean by this is minimizing the movement of data. So on a non-Exadata platform, storage is a subsystem. The data has to go from the storage to the database server. Within Exadata, because Oracle own the full end-to-end stack, they can put code at the storage layer. So they can push predicates down to the storage. So for example, if you had a 1 terabyte table and you wanted to query a predicate that only had 10% of the data in a non-Exadata platform, traditional platform, you would query that, and all the 1 terabyte would be read from disk, have to go through the network, and then on the database server, it would have to read it and filter away 90%, and then give you the 10% on Exadata. It's able to push that predicate to storage. The storage then filters it, gets rid of 90%, and then returns only the 10% through the network. And thing is, backend storages are getting faster and faster with Flash, but the network now becomes a bottleneck. So this is one of the beauties, as well as many other beauties of Exadata, which is a part of the autonomous database. The last final thing of the makeup of autonomous database is the actual cloud, Oracle Cloud automated data center operations. And what we mean by this is on the actual full stack, including operating system, Oracle are able to do through automation patching. So for example, they can patch operating system using Oracle Case Splice, and they can do this all online, as well as they can patch the RDMS, grid infrastructure, etc., etc. Some of you may be thinking, well, on Exadata, you can some degree do that already, but with Exadata, typically patching is done through Oracle Platinum Services, and that's only done on a quarterly basis. And for example, if a critical issue came out, like a CVE, then you're not going to get that change until the next quarter with Autonomous Database. As soon as the CVE comes out and the bug fix is available or the patch is available, Oracle seamlessly apply that to your database or GI or infrastructure to mitigate that issue straight away. So with these three things together, this is what effectively makes up the makeup of Autonomous Database. Okay, as I can't see any people, if through the chat, if you could just let me know if you're still following or if there's any questions, I'm more than happy to go into more detail if required. Okay, so I see a yes so far from Rishan, so that's great, thank you. Okay, so now moving on to Autonomous Database benefits. Okay, so the first thing is it's self-driving. So what this means is basically all the infrastructure management, administration, monitoring, tuning, all of that good stuff is done automated. So what we mean, so auto provisioning. So whenever you provision a database, an Oracle Autonomous database, it's natively out of the box, fault tolerant and highly available. So what that means is it's a clustered database. So you have 2 instances. Yeah, so it's fault tolerant. It removes all single point of failure, and that's again through the Exadata hardware, because everything's got redundancy. Moving on to auto configuration. Whenever you select the size of the autonomous database, Oracle then uses t-shirt sizing to then give the appropriate SJ and PJ, so you don't need to do any of that. Again, when we now move on to data formats, access structures, so this is like HCC or partitioning, indexing, all that sort of stuff. It's all done behind the scenes through machine learning. So effectively all Oracle want you to do is provision the autonomous database, load your data in there, and then just start using it. As your workload evolves, Oracle is monitoring this all in the background and then effectively does all SQL tuning, performance tuning, etc. in the background. which then optimizes your response time. Which moves on nicely to auto indexing. So this is one of the features of autonomous databases. As your workload is continuously working, Oracle is using machine learning in the background to monitor that workload. Where it suspects an index would be beneficial, it will then first go and create that index, but make it invisible. It will then verify that that index is actually beneficial. Once it verifies that, it will then enable it, and then your workload will start making use of that. Equally, once all indexes are obviously being made, they're continuously monitored for the opposite. So, and if an index becomes no longer beneficial, and obviously the maintenance of updating index in terms of DLL outweighs the actual benefit it returns, then Oracle will drop that index. Another key benefit of autonomous database is natively out of the box, it has auto scaling. So what we mean by this is you can set a minimum OCPU and a maximum OCPU, and then autonomous database will happily sit at your minimum, assuming that is enough to cater for your workload. As soon as your workload gets a peak, it will transparently monitor that and increase the OCPUs just to match your workload. So for example, if you're starting off with a minimum of 2, it'll run at 2, a batch comes in, starts needing more CPUs, or there's multiple batches running, or multiple OCP type connections, sessions, I should say, and that then needs to go up to 6, 7, 8, it will just automatically ramp up to the defined set maximum use set. And then conversely, on the opposite, when your workload starts to go down, Oracle then drop that OCPU from, let's say if you had a max 10 all the way back down to your minimum of 2, which is great. Again, natively out of the box, when you create a autonomous database, it comes with a auto backup, which basically means you have daily backup. So every week, one day of the week, you'll have fulls, and every other day you will have incrementals. And then this is in an Arman retention policy for 60 days. So with your fulls, your incrementals, archive logs, and online redo logs, which are multiplex, it allows you to go back any point in time from now all the way to minus 60 days. The final thing, similar to what I mentioned earlier, it has the ability to auto patch itself, hence part of the self-driving. So it can do CVE mitigations at the operating system level or a database, GI. It can apply critical patch sets. It can apply release updates, which obviously include CPUs. It can do auto upgrades as well, and Oracle say all with 0 downtime. I'm a bit more realistic, and I put quotes around 0 downtime to say actually it's more near 0 downtime, because effectively a lot of the patching is done through rolling patching, which basically means you have a cluster database. The first node goes down for patching, it's come back up, and the second node goes down for patching, then comes back up. But for that to be fully realized, you need to have an application tier that is rack aware and is able to reconnect to the available instance when one goes down for patching. Okay, does that make sense? Any dialogue in the chat would be great. Okay, I'll take the silence as everyone's still following and not falling asleep. Okay, moving on to the next feature of autonomous database is it's self-securing. So what Oracle say is it automatically applies security patches. So if you can remember back to, I guess, 2017, 2018, when we had the Spectra and Meltdown vulnerabilities. So once all the CVEs came out and all the patches to mitigate the vulnerabilities became available, a lot of IT workforces out there were patching their IT infrastructure, which was quite a bit of an effort, and obviously it was to mitigate the risk, so it had to be done as soon as possible. Whereas in autonomous database, you don't have to do anything. You're subscribing to a service, Oracle do that for you and do it all behind the scenes automatically as soon as that patch is available, without any impact to you, but immediately giving you the reassurance or giving you that security in the sense of mitigating that vulnerability. The next thing is everything's auto encrypted through the use of transparent data encryption. So that's the database at rest. And this then also transpires into the backups are also encrypted. And in addition to this, and also all your network traffic. So this is your TNS traffic between your client and database is also encrypted. So nobody can eavesdrop or try and pick your data at rest because it's all encrypted. And the final point is there is no access to the operating system. So whereas, for example, OCI DBAS, you do have access to operating system with autonomous, you only see the database as an endpoint. So this has twofold benefit. One, it stops your internal users maliciously doing anything, intentionally or not intentionally. Also prevents Oracle Cloud Operations doing anything maliciously because they are only able to access the operating system indirectly through the automation, and that's for applying patches, etc., etc. And then the final thing, obviously, because of all these features, it allows for auto data protection. So basically eliminates all those concerns about cyber attack on unpatched environments that are vulnerable, as well as databases that are unencrypted. So therefore, you can't steal the data and try and bribe the customer to pay a ransom to get that data back, because effectively they will only have encrypted data. Okay, again, nobody's on camera, so if we can go back to chat. Is everyone following? Any questions so far? Happy to clarify if there are. Okay, very quiet audience. I'm hoping you can still see me presenting. If I could get a yes in the chat, that'd be great. Okay, I've got a yes, that's great. Thank you. Okay, on to the final point. So it's self-repairing. So part of the autonomous database, it has the mechanism to auto-detect issues and resolve them automatically. So for example, there, block corruption, if you've got block corruption on your primary database and you have the physical standby, then this physical standby is open as active data guard. And effectively, once you hit a block corruption on primary, transparently behind the scenes, it will go to your physical standby, it will retrieve the clean copy of that block, and it will transport it over to your primary database. It will then apply that block to your corrupted block, making it non-corrupted anymore, and then serve the query that hit the block that detected the block corruption. So that's all done transparently without having to raise an error to the client, which is great. Also ensures high availability, again, natively through the use of RAC. So again, if you lose one node and an instance, then you can always access the cluster database or autonomous database in this regard through the other instance that has access to the clustered database. With all these features and others, it's able to prevent downtime, including unplanned maintenance. And Oracle, as per the SLA documentation policy, says it will give you 99.95% and above, which translates to only less than 22 minutes of downtime per month. And that also includes patching, which is quite brilliant. If you then opt for the optional auto failover, which effectively is a physical standby, which is open using active data guard, and is actually within the same region, but just within another fault domain and running in max protection. So there is zero data loss. Then the actual SLA then goes up even further to 5 or 4 nines, I should say. So 99.995%, which is actually less than only 2.5 minutes per minute, including patching, which is quite impressive. Okay, so now moving on to, well, why have autonomous database? So these are quotes pinched from Oracle's website. So effectively, they're saying that databases are now storing critical business information. To be honest, I think that was always a given. If you've using Oracle Enterprise Edition. It's an enterprise level database. It does come at a cost, so you can deduce that it's going to have critical business information in there. The next point they're mentioning there is that DBAs are pretty much overburdened with tedious kind of time-consuming tasks managing the database, and that is quite true. And as the database has evolved over the many years, decades, and has increased in number of features, the actual effort to manage the database has increased. And also with the invent with ASM, which is now taking storage administration to database, that's also made it more time consuming. And then if you think about rack, then you've got the rack maintenance as well. And then if you think about Exadata, then you've got all the hardware. So yeah, the DBA job is just n-fold getting more. And ultimately what Oracle is saying then is if people get overworked and overburdened, then it's just natural that human error is going to creep in, which then can have a catastrophic impact on your uptime, performance, and security. So the real only way to mitigate that is just to ensure you have a large enough workforce that can manage it, or even better, have an autonomous database that takes away all the time-consuming kind of tedious tasks and allows your DBAs to more focus on the business value, so and the actual data. So so they're focusing on adding value rather than doing the mundane kind of administration. Okay, so I'm hoping everyone's still following. So now on to the different types of autonomous services. So there's 3 types. The autonomous data warehouse. This was the very first autonomous service that was released early 2018. This is for data warehouse, data marts, data lakes, uses machine learning to learn your workload, optimizes complex queries, stores it in columnar format rather than row format, can use HCC, so hybrid columnar compression, which is available on Exadata, can use database in memory to create data summaries, etc. So it's all geared for data warehousing type workflows. Then the next one, which is autonomous transaction processing, which came out late 2018, was geared for your OLTP environments, your batch environments, your reporting, your IoTs, application development. Again, uses machine learning to optimize response time. Instead of being stored in columnar format, this is stored in the conventional row format. As mentioned earlier, can create indexes automatically, can create packages if required, etc., etc. Someone may ask, what if you have an actual mixed workload that has data warehousing and OLTP? Then Oracle recommends you to go for ATP. Okay, and then the final service that's available, which came out last year, is the Json autonomous service. This is for your JSON-centric applications. The only difference here compared to other JSON databases out there is it's high performance, because obviously it's on Exadata, and also other JSON databases don't all necessarily conform to ACID model, whereas this being a Oracle relational database obviously does conform to ACID, but then is obviously adapted for JSON's use. Is that all clear? Everyone still following? You're a quiet bunch. You're quite hard to please, but hopefully you're all following. Oh, I see. At least I'm listening and seeing. Okay, thank you very much. Okay, so that one's answered. Okay, moving on. Okay, so now we come on to the infrastructure side of autonomous database. So the first one is shared infrastructure. This was the only available infrastructure at launch. So that was early 2018. As per Oracle documentation, this is for non-mission critical workloads. What Oracle mean there really is ideal for non-prod or smaller applications or systems that are not sensitive to performance, because at the end of the day, it's non-deterministic performance, and that's a given if it's shared infrastructure, because you'll have noisy neighbors. So one day you might have a lot of resources available and your query runs a lot faster, and the next day you might not have so much resources because there's many workloads running on the same infrastructure, and then it takes longer to run. Yeah, as per documentation says, it's serverless Exadata cloud infrastructure. One thing about this, because it's shared, is all customers are on the same software version, so that takes it down even to the update level, security patches. Effectively, Oracle dictate what version you're on, and they just effectively tell you, and then that once they apply that uniformly, that applies to everybody. So that's just one downside of being on the shared infrastructure, but it's really geared for those customers that just really want to be a database user and just have a database endpoint, don't really care about how the database operations work, including what version it's on, etc., etc. The beauty of the shared infrastructure is actually its cost point. So this is the lowest cost entry point, which is 1 terabyte of storage with only 1 OCPU. And again, you can only, one of the additional benefits is the minimum commitment is just 1 hour. So you could spin one of these up, have 1 terabyte, 1 OCPU, use it for an hour, see if it's right for you. If you're not, then you can terminate it, and then all your costs stop there. Moving on to the next type, the second of the 3 types of infrastructure available is the dedicated infrastructure. So dedicated Exadata cloud infrastructure. This came out a year later, available in 2019. This one, Oracle was saying now, are for mission critical workloads, and is deterministic performance, because all the resources are now available for yourself and yourself only. So it's just within your workload, so you can get predictable performance, for example, for batch. This is now offered in the conventional Exadata sizes, excluding the elastic configuration. So you have the quarter rack, the half rack, the full rack. It is a database private cloud in the sense that you have hardware enforcing virtual cloud networks. You do get the highest level of isolation, so there is no noisy neighbor other than yourself. Beauty of dedicated infrastructure, you can have multiple CDBs or container databases with multiple PDBs, which you're not able to do on shared infrastructure. You then would have to have multiple autonomous databases using shared infrastructure. So you'd have one with 1 terabyte, another one with 5 terabytes, for example, and one with 2 OCPUs, another one with 3. Whereas here, because you have the platform to yourself, then it allows you to then have multiple CDBs and PDBs. The storage, the usable storage is in line with the rack size, so the conventional Exadata rack size. So with the X8, that's the latest. You get 150 terabytes for a quarter rack, you get 300 terabytes with half rack, and then you get 600 terabytes with a full rack. With this, there's a minimum commitment of 48 hours as opposed to 1 hour on shared infrastructure. So you have to have it for a minimum of 2 days, but the minimum OCPU commitment is only 1 OCPU. Okay. Right, and then the final infrastructure offering is the Exadata Cloud at Customer. Effectively, this is the same as the dedicated Exadata Cloud infrastructure, so the second option, but this was only made available as of last year. And this is for those customers that want to have the cloud benefits, but can't have the data in Oracle's cloud. So whereas this then is on your premises. So this could be for reasons of sovereignty law, where it requires the data to stay in the country of origin. It could be due to latency. So you might have applications that are latency sensitive, but they can't move to the cloud, Oracle cloud. So therefore, you would have Exadata cloud at customer with autonomous database on top of it, and then it'll be co-located with your on-prem applications. That same point goes with integration, and then the last point being risk could be again down to GDPR, sovereignty laws, etc. Already mentioned it's same as dedicated infrastructure, but the last point there is also available in dedicated region. So if those are not familiar with dedicated region, I think it was just over a year ago, probably a year ago, where Larry announced the dedicated region, which effectively is a slither of Oracle Cloud in your data center. So effectively, you're able to spin up whichever Oracle Cloud services you wish, but it does have a minimum $500,000 spend per a month. So it's really geared for the high-end enterprise customers. Okay, so moving on to always free autonomous database. Free is always good. With the free autonomous database, the always free autonomous database, it does come with some caveats. So it has some restrictions. So it's got fixed specifications. So you can only have one OCPU. You can't scale that. So there is no max. It just stays at one. You only get 8 gigabytes of RAM, and you can only have up to 20 gigabytes of storage, and you can't scale it beyond the 20 gigabytes. You can only have a maximum of 20 simultaneous database sessions. Yeah, so that's the restrictions. If you ever max out on any of these restrictions, you can then upgrade to one of the paid offerings. But once you've kind of moved from free to paid, then you can't go back. So these are more geared for the very small workloads or more experimental, et cetera. And workload types you can select is the autonomous data warehouse, the autonomous transaction processing, the JSON, and then as of quite recently, the new Apex. And so the Apex is the always free autonomous Apex application development tier, which is an all-inclusive and fully managed service with up to 1 OCPU and 20 gigabytes of storage, can support approximately 3 to 6 users accessing the Apex application simultaneously, but you can have unlimited number of applications and developer accounts and end users. You can select Oracle Database 19C. They used to have 18C, but that's dropped off now, and they now offer you Oracle Database 21C. So on the always free, they are offering the latest cut, but this hasn't quite made it to the paid services. I think Oracle are just trying to more embed it in on the always free, and then once it's stable, then they'll make it available on the paid services. Obviously it's free, so it's kind of given. This is all unshared X-State infrastructure, so it's not dedicated. And above and beyond this, Oracle do monitor your always free autonomous database. So you need to have activity within a 7 days period, because if you have no activity for 7 consecutive days, Oracle will then stop your autonomous database. Once it's stopped, they will continue to monitor it, and if it's not being restarted within 3 consecutive months, they will then terminate that. And by terminating, that means all the data, etc., will be all lost. Okay, is everyone following? Any questions? I was hoping to have questions throughout so we can keep it interactive. So if anyone's got any questions, more than happy to answer. We're only 33 minutes in. No questions? I can only assume then I'm clearly explaining it. Okay, so moving on to licensing. So licensing is a very complex topic, but this is just the nuts and bolts of it, the basic premise of it. So in an Oracle Autonomous databases, there's 2 types of licensing, and license included, which basically means it includes all the licenses you require, such as Enterprise Edition, rack, and multi-tenant. So you're paying for the consumption of the platform, the CPU, as well as all the Oracle licenses. Whereas bring your own licenses, basically you've got perpetual licenses. You still need to pay those support costs as you do it existingly, but you just then pay for the platform, which is effectively the hardware and the OCPU usage, which is significantly less because you're not paying for licenses because you got that separately. But if you want to go down the bring your own license avenue, then if you have an autonomous database between 1 to 16 OCPUs, then for every perpetual license you have of Enterprise Edition and multi-tenant, you need to have both, then you may activate 2 OCPUs in the Oracle Cloud. And then if you have named user plus, for every 25 NUPs you have of Enterprise Edition and multi-tenant, you're allowed to activate one OCPU. So you have to check what your entitlement you have and what OCPU it allows you to have as a maximum, so you're not in any license compliance issue. If you go up equal to 17 and above OCPUs, then in addition to the Enterprise Edition and multi-tenant, you need to have rack licenses as well. So it's imperative you make sure you're compliant. But yeah, effectively you have two models, license included and bring your own licenses. Bring your own licenses. Okay, moving on. Okay, on to Oracle Autonomous Database costing. So just first of all, point out that these prices have dropped over the year. So last year, for example, the top two were £1.06, and whereas the bottom were 23 pence, but 26 pence, which has now dropped to 23. So if you want to go for license included, like I said, it includes all the licenses as well as the platform, the hardware cost, as well as the old CPU. That's 96 pence per hour for autonomous data warehouse as well as transaction processing. If you go down the route of just bring your own license and just paying for the hardware and the OCPU, that goes down to 23 pence for data warehouse and transaction processing. But you may notice that Json is actually the same price as bring your own license, and the reason for this is actually Json doesn't require any database licenses, so you're only just paying for the platform and the OCPU. Again, just explicitly say this is per hour, and then yeah, if you then extrapolate that to get your monthly cost as well as yearly cost. Well, yeah, one point to make: the JSON database. You can obviously use the JSON's tier on the free, and you can upgrade that to the transaction processing or data warehouse, which then you are now using database licenses. But once you upgrade, you can't then go back again. Okay, now talking about the actual infrastructure. So, sorry, the previous one was all about OCPU, I forgot to mention. Yeah, so it doesn't really include the platform cost, that's here. So that was just the OCPU, so it's the CPU burn rate or the CPU allocation you're paying for. Whereas this one is now talking about the platform. So shared infrastructure, you only pay for the storage, and it's charged per terabyte per month. That's quite a differentiate. You're paying per month, and it's per terabyte, whereas on the dedicated infrastructure, you're paying per hour, and you pay according to the rack size, so quarter, half, and full. And obviously with the size then comes in the how much usable storage you can get. So quarter rack gives you 150, half gives you 300, full gives you 600. And you can see the cost goes up linear. So it's £10.35 per hour for a quarter rack, which then doubles to £20.70 for half, and then doubles again for full rack to £41.40. Okay, so now going on to disaster recovery. So the relationship between your primary and your physical standby from a storage point of view is a one-to-one mapping. So if you have 1 terabyte in primary on shared infrastructure, you need 1 terabyte in physical standby in shared infrastructure. If you have a quarter rack in primary, then you need to have a quarter rack in physical standby. The only difference is really the OCPUs. On your primary, you can have a higher OCPU. So you may say you want to have a minimum of 2 up to a maximum of 10, and it may average you run at like 6. Whereas on the physical standby, because it's only running your redo stream and not any of your actual workload, then that OCPU burn rate can be significantly less. So you could say minimum of 2 and still have a maximum of 10, but it might only run averagely on 2 to 4, etc. And it'll also scale up and down as your workload for the redo also scales up and down. So hopefully that all makes sense. Still no questions? Okay, 39 minutes, so I best speed up. Okay, so to give you an example of costing on shared infrastructure, the first 2 columns are to license included. The last 2 columns bring your own license. So we've got example here of 1 terabyte of storage, 4 OCPUs. Storage cost would come out at £84, or well, just under £85, which is the same if you license included or bring your own license, because that's the platform. The big difference is actually at the OCPU, because this includes licenses, this doesn't. And you can see that's just under 3,000 per month for 4 OCPUs, where it's only just under £700 per month for the same 4 OCPUs. On the DR, because I've just taken 2, so bear in mind autonomous scales automatically, so I'm just taking static averages just to give for illustration purposes. But for DR, I'm saying 2 OCPUs, which is half of the OCPU cost here, plus the storage, which is this cost, which then means overall for a month it's just under 4,500, license included, and just over 1,000 bring your own license. And then I've got 2 further examples here, so 5 terabytes and 10 OCPUs, and then 10 terabytes and 20 OCPUs. But the key thing is here, 20 OCPUs is higher than the 17, so you then have to make sure you have enterprise edition, multi-tenant, and rack licenses when you do bring your own license. You got to make sure, it's imperative for you to make sure you're license compliant. Okay, any questions? Everyone's still following? Yep, I guess so. Okay, onto dedicated infrastructure. So this is all based on X8. I know X9 has only just come out, but Oracle haven't released the pricing for that. So that I expect that to come out in the next few months. Here is now talking about rack sizes. So we've got an example of quarter rack, half rack, and full rack. But I've kept the OCPU the same across just to keep a uniform example. So you can see the infrastructure per month, just under 8,000 for quarter rack, which then doubles for half rack, which then doubles again for full rack. So that's linear scaling up. If you compare that with bring your own license, again, it's exactly the same because the platform cost is the same. It's only the OCPU that varies. So if you look at here, OCPU cost here 14,000 or just over 14,000 for license included, compared to the 3,500 bring your own license. So that delta is the same throughout. But as you see, as you go from the quarter rack to half rack, the difference between bring your own license and license included is quite big. But as you get to the bottom, that delta starts to get less because then the infrastructure cost starts to increase. Okay, so I'm hoping that everyone follows that. The only thing to point out there is for DR, I've just shaped it at 2 OCPUs for the top 2 and the bottom one with 4 CPUs. So it's a slight difference there when you're going up. Okay, still no questions. So moving on to, oh, actually, if I just quickly go back, one point to make, actually, I'll make that point later. Okay, so moving on to alternative solutions in terms of autonomous database is other OCI services, just to give you some comparison. So if you went for bring your own license and you went for IaaS on the latest X9 platform, so you've gone for the IaaS virtual machine, that is only 4 pence per hour for OCPU. It does require you to bring your own licenses. The compute VM is on IaaS basis X9. I've just put a asterisk here saying max 32 CPUs because actually Oracle haven't published what the max instance size is for X9 when I last checked, but based on X8, I believe it will be 32 OCPUs. So with IaaS, you're only getting it as an infrastructure service. So you have to build a software stack, which is install Oracle. You then have to create the database, etc., etc. But that does, all of that doing manually does come out of the benefit of a reduced cost. So you're paying 4 pence, but you can't have rack because rack is not supported on IaaS. Rack is only supported on DBAS, virtual machine, which is one node gives you max 32 OCPUs, whereas 2 nodes give you max 64 OCPUs using 2 node rack cluster. So IaaS comes in at 1/5 of the price, whereas DBAS comes in at 40% less autonomous. But the higher the OCPUs you go, you then have to go from IaaS to DBAS, and then if you exceed the 64, then you need to go into Oracle X-Data Cloud Services or Oracle Autonomous Databases. Okay, still more questions, so moving on. Alternative OCI services. So this is where we're looking at DBAS now and license included. So if you go for Enterprise Edition, which includes diagnostics, tuning, some lifestyle packs, then you're paying 31 pence. If you go for high performance, which is the same, plus you get advanced compression, security, and multi-tenant, then that cost goes up to 63 pence. And then if you go up again to extreme performance, that includes the same as high performance, but also includes rack. Does anybody, just a question here, just to make sure you're still watching, and does anybody notice anything on this slide? Hopefully somebody spots it. Come on, be brave, call it out in the chat. Or if anyone would like to speak. I'll give you 5 more seconds. Okay, nobody has noticed. The actual extreme performance is actually the same price as autonomous. They're both 96 pence. So that begs the question of, when you get to extreme performance DBAS, you might be able to build a business case to go autonomous and not have to do that manageability and let Oracle do the management. But you just have to see what's right for your business case and what's most appropriate for you. Okay, so moving on. So the last comparison I'll do, so you've got autonomous database here, license included here, bring your own license here, going across 3 different flavors, so 1 terabyte through to 10 terabytes, 4 CPUs through to 20 CPUs. So you can see if you look at IaaS, which is this column on bring your own license compared to bring your own license on Exadata, you can see it's 1/5 of the cost. So for that 1/5 of the cost, you have to manage it all yourself. Whereas if you go autonomous, then it manages the platform for you as well as the database internals. If you then move on to license included, so now comparing this with these ones here, Enterprise Edition is 1/3 of autonomous cost. If you go into Enterprise High Performance, it's 2/3 of the cost. If you go into Extreme Performance, then it's effectively the same cost as autonomous. The slight differences there is just the storage cost, because the storage cost on DBAS is much cheaper than Exadata storage cost, but you get significant throughput on Exadata, which is almost 10 times what you'd get without non-Exadata. So for the extra 2K, you're getting a lot more benefit on autonomous. And then you go down here, you can see the different examples. Anything to mention? So yeah, the storage for the compute, just to mention, and the DBAS, I've not put any performance units on there, but I have included extra space for redo logs. And for the IaaS, for the memory, I've gone for 32K and kept it consistent across just to give that price comparison. Okay, so moving towards the end of the presentation now. So is autonomous database right for you? Well, end of the day, it can be perceived as expensive, but as I've shown, it can be as equally as expensive as DBAS. So when you get to the DBAS extreme performance, then you can actually build a business case to go to autonomous. It does significantly reduce your administration effort from a platform point of view, as well as inside the internals to the database. So then your DBAs can pivot from being what would you call it, traditional DBAs, to becoming different companies call it different things, but it'll be like data engineer, data scientist. They become more aligned about the business than the operation, so they can add the value add. There are alternatives, as I showed towards the end of the presentation. So there is the IaaS. You could have that with a managed service provider, and then they can manage the platform and some degree the internals of the database for you, and then you just look after the actual internals of the database in terms of, your schemas and stuff. You could also have a DBAS with a managed service, but if you want that true automation, true autonomy, what the autonomous database gives, then you can go for autonomous database. It all comes down to personal requirements and what's right for you. Okay, so one caveat of this whole presentation, the autonomous database is constantly evolving. I've checked the whole presentation, it's correct as of this month. But even just a few months go by, a lot of things change, which could be service offerings, licensing, costing. As I checked last year and this year, pricing has changed. So I always say, if you're going to go for autonomous database, please do your own due diligence or work with a Oracle Cloud partner such as ourselves, version 1. And that brings us to my end of my presentation. So thank you very much for listening. That's much appreciated. Just a reminder, if you can follow me on social media, you can use this QR code here. And now on to any questions which I can kindly answer for you. So is there any questions? Is everyone still awake?
Please, at least someone say that you are awake.
Yeah, thank you. So, okay, I've got a thank you. So thank you very much. You're most welcome.